Before humans walked on the moon, before space stations, before weather satellites quietly watched Earth, there was a small metal sphere sending a simple beep through the sky. On October 4th, 1957, the Soviet Union launched Sputnik 1, the first artificial satellite to orbit Earth. It was not a spacecraft with cameras, astronauts, or complex instruments. It was closer to a proof of possibility. A polished sphere with antennas, a transmitter, and a signal anyone with the right radio equipment could hear. That sound mattered because it answered one of the biggest practical questions of the age. Could a human-built object reach orbit and stay there falling around Earth instead of falling back down? Sputnik showed the answer was yes. Orbit is not just being high up, it means moving sideways so fast that Earth curves away beneath you as you fall. Sputnik crossed that threshold. It turned space from a distant idea into a place machines could actually enter. What was known at the time was simple and world-changing. A satellite had been placed above Earth by human engineering. What remained uncertain was almost everything that would follow. Could people survive the trip? Could spacecraft be controlled reliably? Could orbit become useful, not just impressive? For scientists and engineers, the fascination was not only the object, it was the new environment. Space exposed machines to vacuum temperature, swings, radiation, and the challenge of tracking something moving faster than any aircraft. Every later mission would have to learn from that first crossing. Sputnik itself did not do much by modern standards, but that is part of its power. It proved that the first step into space did not need to be giant. It needed to be real. The memorable takeaway is this: the space age did not begin with a footprint. It began with a sound passing overhead in the dark. When Sputnik crossed the night sky, it was more than a science achievement. It was a message in orbit. In 1957, the world was living through the Cold War, a tense rivalry between the United States and the Soviet Union. Rockets were not just tools for exploration. They were also symbols of engineering power, national ambition, and military technology. So when the Soviet Union placed the first satellite above Earth, many people understood the meaning immediately. If a rocket could put a satellite in orbit, rockets had entered a new era. That is why Sputnik caused such a powerful reaction. The satellite itself was small. The implications were enormous. At the time, scientists already knew the basic physics of orbit. They knew that reaching space required extreme speed, careful guidance, and a rocket powerful enough to overcome Earth's gravity. But knowing the physics was different from proving the engineering. Sputnik proved that a working launch system could deliver an object into orbit and keep it there for the world to track. What was known was the fact of the achievement. What was uncertain was what it meant next. Would space become a battlefield, a laboratory, a place for communication, or all of these at once? No one could fully know that uncertainty shaped politics, education, and research for years. The United States responded by accelerating its own space efforts. NASA was created in 1958, bringing civilian space exploration into a new national structure. Schools placed greater emphasis on science and engineering. Radio listeners, astronomers, and ordinary families began to feel that space was no longer an abstract frontier. It was overhead. Sputnik matters because it changed the emotional scale of Earth. The sky had always been distant. Suddenly, human technology was moving through it. The takeaway is not simply that one country launched first. It is that one satellite forced the world to take space seriously. And once that happened, there was no going back. Every time you check a weather forecast, use satellite navigation, watch live events from across the planet, or hear about a telescope in orbit, you are living in the world. Sputnik helped begin. Sputnik 1 was not designed to become a global utility. It did not map Earth in detail or connect continents with television signals. but it opened the door to the idea that orbit could become useful. Once engineers proved that a machine could survive above Earth and be tracked from the ground, the next question became much bigger. What else could we place there? The answer now surrounds the planet. Satellites help monitor storms, study climate guide ships and aircraft support communication, observe crops, track changes in ice, and give scientists a view of Earth that no person on the ground can have. Space. History is not sealed away in old photographs. It is woven into ordinary life. But Sputnik's legacy is not only practical, it also changed how humanity imagined exploration. After Sputnik came animals in space, then people, then lunar missions, planetary probes, space stations, reusable spacecraft, and robotic explorers far beyond Earth. Each step was more complex than the first satellite, but all of them depended on the same breakthrough reaching orbit reliably. There is still uncertainty in spaceflight. Rockets remain difficult. Space is harsh. Missions can fail. Engineers test, revise, and learn. Because orbit is not routine in the way roads or oceans feel routine. It is a demanding environment that only looks calm from far away. That is why scientists and engineers still find Sputnik fascinating. It was simple, but it was decisive. It turned a dream into infrastructure. It made the first thin bridge between Earth and space. The memorable takeaway is this: Sputnik did not just start a race. It started a relationship. Humanity became a planet with objects in orbit, and today, that invisible ring of machines is part of how Earth understands itself